Measurement of conductivity. What is the conductivity formula? Conductivity is equal to G star, that is cell constant, by resistance. So we already know that G star is nothing but cell constant. Cell constant is equal to L by A, length upon area. Now, to calculate the conductivity, we should know G star, cell constant, and resistance should be known. Therefore, first we have to calculate resistance and cell constant. So, first of all, we have to calculate anyone that I am calculating first resistance. How to calculate this resistance? By using Wheatstone bridge. When you use the to calculate the Wheatstone bridge, resistance of any electrolytic solution by using Wheatstone bridge, first of all we will get the two problems. First problem, when direct current is passed, DC means direct current is passed, then what happened? Electrolysis takes place. It means chemical change takes place. It is difficult to calculate. Therefore, to overcome this problem, what we have to do? Use direct AC current. Instead of direct current, use the alternate current. Then, second problem number 2, difficult to connect. Difficult to connect to the Wheatstone bridge. The whatever the electrolytic solution is, it is difficult to connect to Wheatstone bridge. Then what is the solution? Solution for this is a specially designed conductivity cell is used. So two problems are faced. The two problem solution also now we got. Therefore, what to do now? By using Wheatstone bridge, we can measure the resistance. What is the formula for resistance? Already we know the conductivity formula G star by R. From this we can calculate R is equal to G star by K. Now, to calculate this one, conductivity unknown, but this generally you R value will get from the Wheatstone bridge. Now R is known, then we can go for second one. What is that? G star calculation. How do you calculate the G star? G star formula is according to this one. So G star is equal to K into R. So now what are known required? Known conductivity and resistance, both are known required. Now conductivity of any one already known solution we can take, and resistance we can calculate by using the Wheatstone bridge. Then multiplying these two values we will get the cell constant. Cell constant, once it is determined, it is a constant. It is a fixed for a any one solution because cell constant means what is there? L by A. So G star we can calculate by using the formula that is K into R. Otherwise, G star, if length and area is known, we can calculate the cell constant value. Therefore, after knowing the resistance and cell constant, now we can calculate conductivity. Conductivity formula, what is it? G star by R. We can calculate. But nowadays, digital meters are used that is easy to measure the conductivity. It directly read the conductivity values. So now conductivity depends on one, different electrolytes in same solvent at given temperature is differ. Reason 1, size and charge of ion. Second one, concentration of ion. Third one, movement of ion under potential gradient. Therefore, a new term is required. That is molar conductivity. That is denoted with the lambda m, otherwise simply like this symbol, that is not exact lambda type. This is called molar conductivity symbol. So what is the molar conductivity? Molar conductivity is definition: the conductance of all ions produced by 1 mole of electrolyte. 1 mole of electrolyte kept between two electrodes having unit distance and area of cross section is 1 unit. Sorry, area of cross section is not 1 unit. That is area of cross section A. Because if it is taken as a 1 unit, that is called conductivity. Now area is not fixed, means that is called molar conductivity. Therefore, now keep in mind, lambda m is equal to conductivity into volume. So because volume is not fixed here, in given volume, whatever the conductance is present, that all conduction total is called molar conductivity. Now I want to take like this one conductivity cell. In this conductivity cell, we have, this is a left side electrode, this is a right side electrode. This distance is this distance is fixed. L is equal to 1 meter. But this distance is not fixed. It means area is not fixed. When area is not fixed, then that is volume, not 1 unit. So volume is not equal to 1 unit. That is, volume is anything volume, that is. Therefore, conductivity already we know. Conductivity for which one? 1 unit volume. This lambda m is for any volume. Therefore, what we have to do? Lambda m is multiplied of the which one? Lambda m is a volume multiplied with the conductivity. In given volume, whatever the conductance is present, that is called conductivity. But already we know that molarity is equal to N by V. For 1 mole, N equal to 1 mole, what we can say now? Molarity is equal to 1 by V. V is equal to 1 by M. Then lambda M is equal to conductivity. V plus we can write 1 by M. Then already we know that M is equal to mole per liter unit. Therefore, lambda m is equal to k by m. In this one we can place k unit, already we know Simon centimeter inverse, and this will be mole. This is molarity per mole per liter. This liter will goes in the numerator. Therefore, I can write this is in numerator L. This can be written as K Simon centimeter inverse. 1 liter equal to 10 power 3 centimeter cube, because 1 liter is equal to 1000 milliliter. Then this is 1000 centimeter cube also. 1 milliliter equal to 1 centimeter cube. If you don't know, then 1 milliliter is equal to 1 centimeter cube. Then now denominator what is there? Mole, that is molarity in mole. Now we can write the units. Here centimeter inverse and centimeter square one cancel, then centimeter square left. Simon centimeter square, mole inverse goes in the numerator, that is called, mole come to mole inverse. In case it is in meter cube is used, then lambda m is equal to k Simon meter inverse. That time this will 1 liter equal to 10 power minus 3 meter cube. Denominator m, that is in mole. What is the unit now? 1 cancel, then 2 left. Simon meter square mole inverse. So according to units, we have to use the which formula you have to decide. So now this is a formula generally present in the all books, because in centimeter cube taken. -3 is there, meaning a 10 power, that is called meter cube respective. That is, you have to carefully remember. So now finally I am once again giving here lambda m is equal to k Simon centimeter inverse into 10 power 3 centimeter cube by molarity mole. Another one is lambda m is equal to k Simon meter inverse into 10 power minus 3 meter cube by molarity in mole. So these formulas we have to remember. Now we know the what is the molar conductivity, we know the what is the simple conductivity. Now, how these are variable with the concentration? Variation of K and lambda m with concentration. This is one time asked in the JEE mains exam also. That's why you have to focus on this one. Also asked in the all board level exams. Now, first I will discuss about the K. I think already I discussed. Once again I am repeating this is on dilution concentration what happened decreases. On dilution concentration decrease and also number of ions decreases. One minute. Number of ions that carries current decreases, that is per unit volume. This is the reason. So on dilution, whatever extra volume is added, that is flown out along the solution, that electrolyte salt also out. Therefore, number of ions will be decreases. So concentration increases, conductivity increases, concentration decreases, conductivity decreases. Now lambda m molar conductivity, how it will be changed? So two reasons I can give here. Actually, at lower concentration, degree of ionization will increase. On dilution, already if strong electrolyte also is there or weak electrolyte is there, strong electrolytes are already completely ionized, but whatever the little amount left, for example, that also easily ionized. So on dilution, 1 degree of ionization increases. Second one reason, force of attraction decreases. When force of attraction decreases, molecules or ions are easily or freely move. Therefore, lambda m increases on dilution, but K decreases on dilution. Very important, these two terms on dilution, what will happen?